Hello, welcome to Operation Research third chapter recap. It is with regarding to the transportation problem. Objective of this session is to understand what is transportation problem, develop an initial solution to a transportation problem, and finally develop an optimum solution to a transportation problem. The objective of the transportation problem is to satisfy the demand at the destinations by supplying from the sources with the minimum transportation cost. There may be several factories all around the country, but to supply it to the warehouse, we need to supply it with the minimum transportation cost. This transportation problem will enable you to find the minimum transportation cost to supply from the outlet to factory or the source to warehouse. Now let's look at the assumptions in transportation problem. Here we are only considering a single type of commodity and the total supply is always equal to the demand. The third one is we know for sure what is the transportation cost. And finally, objective of this transportation problem is to minimize the total cost. What are the types of transportation problem? There are two types of transportation problem. The first one is the balanced transportation problem and the second one is the unbalanced transportation problem. In the balanced transportation problem, the supply and demand is always equal. And in the unbalanced transportation problem, the supply and demand is not equal, which means it is unbalanced. In an unbalanced transportation problem, there can be excess demand or excess supply, which means demand can be greater than supply. In the excess demand or in the excess supply, the supply may be greater than the demand. In this case, to balance both sides, we are adding a dummy variable. In the excess demand, we are going to add the dummy to the supply side, and in the excess supply scenario, we are going to add the dummy to the demand side and making it into a balanced transportation problem so we can solve this question. Now let's look at what are the methods to solve the transportation problem. Initially, we are using three methods to find the initial feasible solution. Those are northwest corner method, least cost method, and the Vogel's approximation method. After finding the initial feasible solution using these three methods, we are going to find the optimum solution by using stepping stone method and modified distribution method. To find the initial solution or the optimum solution, we have to satisfy the basic requirement. The basic requirement is the demand should be always equal to the supply. If the basic requirement is not satisfied, we have to substitute a dummy row or column to make it balance. Then only we can follow the initial feasible solution and finding the final answer using the optimum solution methods. Now I would like to pay your attention with regard to 2019 past paper question. Please see, this is the question available in your past paper. Here there are three stores 1, 2 and 3, and the supply from these stores is equal to 2250. And there are three factories, F1, F2 and F3. These three factories need the demand as 2250, which means the supply is equal to demand. This is a balanced transportation problem, so we don't need to add a dummy row or a column. Now let's see how to find the solution. Now let's see how to find the initial solution using northwest corner method. In the northwest corner method, we are going to first allocate to the northwest corner cell. Here, the first northwest corner cell is the F1 S1. How much of quantity we should allocate? 350 or 500. Here, we have to select the lesser amount, which means even though if one factory can supply 500 units, S1 need 350 units. Therefore, we are going to satisfy the lesser amount. When we allocate 350 units to F1 S1, then all the demand is satisfied for the S1 store. Therefore, no need to supply from any other factory. Therefore, I will hide this S1 column. Then, what is the next northwest corner? Before allocating to the next northwest corner, we should remind that when we allocate 350 from factory 1, we are only left with 150. Therefore, we can allocate only 150 to the next northwest corner cell, that is F1 S2. When we allocate 150 to that particular cell, all the supply is fulfilled from the F1 factory. Therefore, we cannot supply anymore. Therefore, I will hide the F1 row as well, because we have satisfied the supply. Then, out of these 4 cells, what is the next northwest corner cell? That is F2 S2. How much of quantity we can allocate? When we allocate 150 from F1 factory to S2, S2 only need 850. Then this 850 can be allocated to F2 S2 cell because they need 850 units, but the F2 factory can supply 950. Here, when compared with 950, the 850 is lesser. Therefore, we are going to select the quantity of 850. Then when we allocate 850 to F2 S2 cell, all the demand requirement of the S2 is fulfilled. That is 150 from F1 and 850 from S2. Then I will hide this S2 store as well. Now you can see we are only left with F2 is 3 and F3 is 3 cells. Out of these, what is the next northwest corner? That is F2 is 3. Then, how much can we allocate? You can remember that from the F2, we have already allocated 850 units. Therefore, we only left with 100 units. So, when we allocate this 100 units to F2 cell, over the supply of F2 is fulfilled. Therefore, we cannot allocate any more to any particular cell. At the same time, all the supply from F2 is fulfilled. That is 850 to S2 and 100 to S3. Therefore, I will hide this cell as well. And you have to remember, when we allocate 100 units from factory 2, we can allocate only 800 units from F3. Why? Because the S3 only need 900 units. Then, whereas the factory 3 only supply 800 units, which means all the demand conditions of these cells are satisfied. Therefore, I will hide this S3 as well. Now, the final one is we have to calculate the total cost. Total cost can be calculated by multiplying the transport cost of each particular cell with its quantity. When we take the first cell, if one is one cell, 45, that is the transportation cost, should be multiplied with 350 units. Then in the next one, 40 should multiply with 150 units. Likewise, all the cell cost should be added together to find the total cost. Here the total cost represents 65,250. Next, we are going to see how to find the initial solution using least cost method. In the least cost method, first we are going to identify the lowest cost from the table. In this question, the lowest cost represent as 10, that is in F2 is one cell. Therefore, we are going to allocate to that particular cell. How much of quantity we are going to allocate? Even though F2 can supply 950 units, the S1 factory needs 350 units. Therefore, we are going to put the minimum quantity to F2 S1 cell. When we allocate 350 units, all the demand condition of S1 satisfied, so we cannot allocate any more from any other factory. Then I will hide this cell. Then out of these remaining 6 cells, what is the lowest cost? Least cost. Out of these 6, the 20 is the next least cost. So, how much of quantity we can allocate? Here, you can see when we allocate 350 from F2, we can only allocate 600 units. Therefore, even though you need 1000 units, we can only supply 600. Therefore, to the next least cost cell, we are only allocating 600 units. And when we allocate this 600, all the supply condition of the F2 factory is fulfilled. We cannot allocate any more from F2. Therefore, I will hide this row as well. Then, out of the remaining 4, what is the next lowest cost? That is 30. Then, how much of quantity we should allocate? Here, F3 factory can supply 800 units, but S3 need 900 units. I always repeat that we should allocate the lowest amount. Here the lowest amount represents the 800. Therefore, we are going to allocate 800 units to F3 S3. When we allocate 800 units, all the supply condition of F3 is satisfied. We cannot supply any more from that particular factory. Therefore, I will hide the F3 column as well. Then, out of these two, you can say what is the next lowest cost, that is 40. Here, how much of quantity we can allocate? The quantity remaining is 400 because we have already supplied 600 units to F2 factory. Then we are allocating this 400 to F1 is 2, and at the same time here we are only left with 100 units from S3 factory, because we have already supplied 800 units from F3 factory, but we still need 100 units. This 100 units will be supplied from the F1 factory to S3 store, and the remaining 400 units will be satisfied by the F1 factory to S2. Now all the demand conditions and supply conditions of these factories are satisfied. Now next option is we have to calculate the total cost. In this question, when we multiply the transport cost from the particular sales, we get the total cost as 60,500. The next initial solution method is Vogel's approximation method. Vogel's approximation method is based on the penalty cost. Penalty cost is the difference between the two lowest cost. And in this question, we are going to identify the penalty cost of each column and each row. In the first row, when we take the penalty cost, the two lowest costs are 40 and 45. The difference is 5. Likewise, we are going to calculate the penalty cost of each row. Then we are going to find the penalty cost of each column as well, using the same method, that is the difference between the two lowest cost. Now out of these 6, we have to select the highest one. That is where the opportunity cost is highest. So we are going to minimize the opportunity cost or the penalty cost. Therefore, we are going to select the highest amount. Here the highest amount is 20. Now we are going to allocate into that particular column. How much of quantity we are going to allocate? Right? In this one, in this column, we have to select the lowest cost to allocate the same quantities. Here, F2 is to represent 20, that is the lowest cost. We are going to allocate to that particular cell 950 or 1000. Here, even though S2 need 1000 units, but F2 can only supply 950 units. Therefore, we are going to allocate 950 to this lowest cost cell. Then when we allocate 950, all the supply condition of F2 is satisfied. Therefore, we cannot allocate any more from F2. Then we are going to find the next penalty cost. Here we are going to calculate the next one. In the first row, the lowest two cost difference is 5, and in the F2 satisfied, therefore we cannot see any penalty cost there because we cannot allocate anymore. And in the F3 row, the difference is 10. Likewise, we are going to calculate for the S1, S2 and S3 columns as well. Out of these penalty cost, the highest one is 10. Therefore, we are going to allocate to that particular cell. Here, in the F3 row, the highest least cost is 20. Therefore, we are going to allocate to F3 S1 cell. How much is the quantity? 350 or 800. I always repeat that we should use the lowest quantity. Here we are going to allocate 350 units. When we allocate 350 units to F3 S1, all the demand condition of S1 is satisfied. Therefore, we do not need to allocate any more to S1 store. Therefore, I will hide this cell. Then out of these, we can see there are 4 remaining cells. In the 4 remaining cells, we are going to select the next least cost, that is 30. How much of the quantity we are going to allocate? Since we have already allocated 350 units from F3 factory, we are only left with 450 units. Then we can put 450 to F3 is 3 cell. Then all the supply condition of F3 is satisfied. We cannot allocate any more from F3 factory. Therefore, I will hide that cell. Then from the F1 factory, we have to allocate the remaining 50 to the S2 store to satisfy their demand condition of 1000, and from the F1 factory we have to supply 450 to S3 to satisfy their demand condition of 500. Now all the demand conditions and supply conditions of these factories are satisfied. Now when we get the row wise, you can see from the factory 1 we have supplied 15 units to S2, 450 to S3. Altogether it represents 500 units. And from the factory 2 we have satisfied 950 only for S2 store. And in the factory 3 we have supplied 350 to S1 and the remaining 450 to S3. When we are getting the total, 50 plus 450 equals 500, 950, 950, 350 plus 450 is 800. Now all the total of the rows are satisfied. Now let's look at the columns. 352 is 1, 50 plus 950 is 1000 for is 2, 450 plus 450, 900 for is 3. Now you can see all the penalty cost and the allocation in a single table. Now, before finding the optimum solution, we have to check the degeneracy in the transportation problem. What is this degeneracy? Basically, we are assuming that the number of occupied or number of allocated cells in should be equal to the number of rows plus number of columns minus 1. When this condition is not satisfied, which means if this row plus column minus 1 is lesser than the occupied cells, we are telling that there is a degeneracy. When there is a degeneracy, to solve that degeneracy, we can allocate 0 quantity to a particular cell and transport from there, assuming there is an allocation. Now, we are going to find the optimum solution using MODI, that is Modified Distribution Method. Here, as I already mentioned, we have to find the degeneracy problem is there or not. In this table, there are 3 rows and 3 columns. And when 3 plus 3 minus 1, the occupied cells is equal to 5. Therefore, we cannot see any degeneracy. See here 1, 2, 3, 4, 5. 5 cells has been allocated. This is satisfied the basic rule. Therefore, there is no degeneracy. We can go for the next step. In the MODI method, we are assuming certain U values and V values for this table. These are arbitrary values, which means we are putting as our preference. Here, we are assuming the basic condition, that is the first row cell, that is U1, is always as 0. That is the basic requirement. In every table, this particular value will be 0. Now, how to calculate the transport cost? Here we are assuming that transport cost is represent the column values and the row values. Therefore, when the row value is 0, how to get 45? Then it should be the column. Therefore, we are putting 45 to the V value. Then the next one. When the transport cost of U is 0, what will be the value for V2? Here we can say the transport cost as 40, because 0 plus 40 should be the case. Here when we put the transport cost 40, the row value as 0, the column value should be the 40. Otherwise, we cannot get the total transport cost. And in the third one, when the V value we mentioned as 40, then what will be this U value? If this value as 40, then how to arrive at 20? Which means we have to deduct 20 to arrive at the 20. From the 40, we are going to deduct 20. Then, in the third one, we are going to find the transportation cost, that is 25. How to get the 25? We have already calculated U2 as minus 20. Then to become a plus 25, we should add 45 to this column value, that is V3 value. And in the final one, the transportation cost we can see as 30. To arrive at 30, we have already calculated V3 value as 45. So we have to deduct 50. This is easy. First, we have to put it into a table. Put it into the table and put the transport cost of each cell. Then go to the first row. In the first row, put the first cell row value as 0 and substitute the values. Then when we substitute the values, we can see it is the way to find the missing answer. When we find the missing answer, put it into the rows and columns according to the V and U values. And in the next one, we are going to find the cost improved index. Cost improved index is find the least opportunity cost cell. When we allocate these cells, there will be certain cells which are unoccupied, which means unfilled cells. In the unfilled cell, what is the cell? If we allocate, we can reduce the transportation cost further. That is the where we are going to find in the next step. Here, the first unsatisfied cell is F1 is 3 cell. Then the transportation cost is 50. When we deduct the row values and column values from that one, we can say the cost will be 5 is uncovered, which means we cannot reduce this cost because they are, when we allocate to that particular cell, the cost will be increased by 5 per unit. Then the next unoccupied or unfilled cell is if 2 is 1. The transportation cost is 10. When we find the cost improved index, we can see it is minus 50, which means by allocating to that particular cell, we can reduce the cost per unit by 15 rupees. Likewise, we have allocated to if 3 is 1, then if 3 is 2 cells, we can see the cost improve index as above. Now, we can see we can further reduce this cost because there are minimum negative answers there. Now, from these negative answers, we have to select the highest one, that is 15. Now we are going to allocate to F2 is 1 cell to reduce the transportation cost in the next step. Now we are going to allocate to the F2 is 1 cell. When we allocate to F2 is 1 cell, from where we are going to take? We can take the quantity either from F1 is 1 or F2 is 2. Then how much of quantity we are allocating? 350 or 850. Here we have to select the lesser amount. Now we can add from either these two cells. When we are removing quantity from that particular cell, to balance that particular row or column, we have to transport quantity from somewhere else, from another adjoint cell. Therefore, when we are adding to the F2 from F1 is 1 to fill the gap of that F1 is 1 cell, to balance this 350, we have to transport from S2 to F1. Then we can see this S2 will be unsatisfied if we transport from this one. So to balance that one, we have to transport from F2 to S2. Then when we transport from this one, the F2 row will be unsatisfied or unbalanced. Therefore, we are going to transport from another F2 to S2. Likewise, when we are transporting, we should remind that we have to balance the quantities and demand in each column without harming any effect. Which means out of these 4 cells, you can see we are going to add to the F1 is 1. What is the amount we are going to allocate? We are going to allocate the lesser amount of the quantities, that is 350. When we are transferring 350 from F1, F1, the lower quantity, the total value of F2 is 1 will be 350. Then when we are transporting the full amount from F1 is 1, it would be 0. And from S2 we are going to add another quantity because to balance this F1 row. Then altogether it will be 500. And when we transport 350 units from 850, the balance would be in the F2 S2 cell would be 500. Based on the allocation, we can get to the table number 2 as you can see. Now we are going to find the transportation cost using this table. The transportation cost arrives as 64,000. Now we are going to find whether this table is an optimum table or not. For that, we have to again calculate the V values and U values. Here I already mentioned that the U1 should be always be 0. Then by using the transportation cost of each cell, we can calculate the V values as well as U values. Here, the first F1 is one cell represent 45 as transport cost. This is the column plus row value. Since the row is 0, the column should be as what? It should be as 40. Then in the next one, F2 is 2. The transportation cost is 10. Since this value is 0, U1, and we cannot find the value because we don't have the V1 value as well and U2 value as well, we are going to find the answer by substituting the values for the F2 is 2 cell. Therefore, in the F2 is 2 cell, we can see the transportation cost as 20. We have already calculated the V value as 40. Therefore, how to arrive at this 20? We know that this 20 represents the row value and column value. If this V value is 40, then we have to deduct 20 to arrive at the positive 20. Therefore, U2 value should be minus 20. Then in the next one, we can substitute this U minus 20 to calculate the V1 value. Then we can find the V1 value as 30. And when the V1 value as 30, we can substitute the same U value to find the V3 value as well. Then to arrive at 25, if the row value is minus 20, the V value should be 45. Then finally, we are going to find the F3 is 3 value. We have already found the V value as 45. Then how to arrive at this 30? Therefore, we have to deduct 15, that is the row value, from this 30. Then by substituting the U values and V values, we are going to find what is the cost improve index. Here there are 4 unoccupied cells. Now the first cell is F1 is 1 cell. The cost improve index of this cell is 15. And in the next one, that is F1 is 3 cell, the cost improve index is 5, whereas if 3 is 1, it is 5, and in the final one, if 3 is 2, it is 20. Since the cost improve index value is positive, we can say it is the optimum solution. We cannot reduce transportation cost further. Therefore, we are going to find the total cost. Here, the total cost is 64,000. In your exam, we are expecting that in the final table, you should write again and mention the optimum table, and then you have to mention the table, you have to draw the table again, and you have to calculate the transport cost again. So we can give the marks to the initial table and finally the optimum table. Even though these are steps, in these steps it is maximize, optimize. Finally, you should draw and you should show it in the final answer as well. Based on the calculations, you can obtain the final optimum table as follows. So in this table, the total transportation cost is minimized to 64,000. Hope you have gained some knowledge with regard to the transportation problem. What are the assumptions? Then how to find the answer using initial solutions, northwest corner, least cost as well as Vogel's approximation, and how to find the optimum solution using MODI method. See you on my next video with regard to the maximization of transportation problem. Until that, take care everyone.